Welcome to the presentation AI-Empowered Learning Models in Economy 5. Before we start, let me pose a question. What is the essence of learning? Please share your thoughts in the chat. I'm Tabea Hirzel, founder of Learning for Tech. For my academic and professional background, please visit my Linktree. Instead of a formal presentation, let me share my early learning experiences. My first memory of learning goes back to kindergarten at age 4. Despite not sharing a common language, I bonded with a Chinese boy and an Indian girl. Together, we invented a game using hula hoops to form 3D shapes like electron paths, which was quite challenging for 3 preschoolers. As a reward, each time we succeeded, we exchanged words in our respective languages. I cherish this game, acquiring new words every day, most probably in Mandarin and Telugu. And my mother still recalls how I taught these words later at home to my family. What I take away from this experience is that we did not search for an incentive to learn, but for some reason the joy of learning itself was the prize for a successful task. Within my multilingual and multicultural family, storytelling played a central role. It wove together our experiences and memories, influencing my research thesis on principles of liberty. A collaborative, historiographic storytelling process aimed at creating a shared vision. With that background and over 20 years of consulting and teaching experience, I joined friends to establish a community learning platform. Operating as Learning for Tech, we are now blending traditional embodied narratives with modern literacy and skills while integrating AI tools to meet educational goals. The challenges we faced in this journey form the basis of my current article. My paper addresses 2 key questions. First, how learning can drive DAOs, decentralized autonomous organizations, and second, the positive impact of AI on learning. Let's go for it. An old Australian Aboriginal proverb states, "There are no paths are made by walking." Conventional learning programs, primarily constrained by the textbook as a key technology, have often been the opposite. Today, education emphasizes skills and competences needed for a various job market. Following global frameworks like UNESCO's ISCED. Many countries offer online tools for lesson planning, such as Europe's Future Classroom Lab and Nigeria's Ignite lesson plan tool. Private organizations assist educators in program development, primarily focusing on content creation and testing, with some consideration for competencies. AI plays a crucial role in automated course creation, with tools like Minicourse, Coursebox, and platforms such as Coursera and Khan Academy using AI-driven content creation and personalization. However, these systems often resemble digital textbooks with standard tests and videos and offer limited didactic resources. While they collect extensive user data, personalization mainly involves learning plans and course recommendations. The approach is generally top-down and teacher-driven, though Khan Academy's Khanmigo aims to improve personalization. Moreover, AI generators for text, image, and video, along with online translators and text review tools, enable educators to create visually appealing online courses quickly, even without technical skills. However, at Learning for Tech, We advocate a community-based approach where learners are empowered to chart their own paths with learning deeply integrated within the community and environment. My course creation approach is distinct in the way it addresses real-time content personalization. Since 2011, I've adapted my methods for quick adjustability, particularly in one-to-one language teaching. Initially, I used a responsive approach within the Content and Language Integrated Learning Framework, CLIL, tailoring content based on immediate learner feedback, influenced by my own background in nursing and psychology. I started with a simple spreadsheet and later integrated educational standards into a PHP MySQL application, achieving only marginal improvement. The game changer was AI, with streamlined content creation, automated processes, and enabled the creation of comprehensive textbooks from spreadsheet data, highlighting AI's potential for full course automation. To address these shortcomings, I've developed tailored content designers using GPT tools for AI driven course creation in 4 sequential steps, which you can see on this slide. This approach, while more time consuming than the former described automated generators, yields fully personalized 20-lesson courses encompassing textbooks, interactive content, and assessments, all crafted within a few days. This enhanced method significantly improves efficiency and aligns content with our specific course materials and objectives. Education is foundational for a thriving economy. As Dr. APJ Abdul Kalam, former President of India, wisely stated, learning gives creativity, creativity leads to thinking, thinking provides knowledge, and knowledge makes you great. Thus, it's vital to assess the role of educational technology, edutech, in enriching learning experiences, especially in the context of Economy 5, where edutech plays a pivotal role in advancing learning outcomes, fueling growth, and driving innovation. The transition to Economy 5 is part of an ongoing evolution dating back to the industrial revolutions since the late 18th and early 19th centuries when modern democracies emerged. This journey includes shifts from early financial systems and globalization to today's tech-driven landscape with AI and blockchain. From the mechanization in Economy 1 through the production of scale in the Fordism of Economy 2, continued by advanced automation in the digitization era towards the development of cyber-physical systems in the current Economy 4. AI has become an unprecedented change maker. It no longer is limited to improve human capacities, but transforms our self-understanding. In this context, EduTech leverages AI and blockchain to enhance learning and actively shape Economy 5, while it changes how we learn. Over the past 4 decades, technological advancements have significantly reshaped our understanding of teaching, learning, and human development. Our goal is to introduce or reintroduce a unique didactic approach inspired by the early days of computer games when learners had to write their own code before they could start playing. 1982, early gamification with coding games such as Frogs and Flies and later saved on floppy disks made the start in this direction. 1990, developments of avatars and icons in Q&A systems such as Microsoft Clipit are genius, maybe a concept still renowned by somebody of you. 2000 Web's 2 Foundation with HTML, PHP, and MySQL enhancing online collaboration was also the start of the launch of Second Life. 2007 was the integration of online and real-world experiences, growth in the open source economy, and Minecraft's impact on learning. 2011 integration of authority controls, LODs, and tokenization of learning outcomes alongside blockchain advancements, and 2016 adoption of distributed planning systems, enhancing scalable learning platforms, and adapting to distributed systems during the COVID era. All this led to the current state in 2022 to now, where content creation is automatized in a virtual environment integrated with the Web 4. In short, a DAO, decentralized autonomous organization, is a blockchain-based entity with the following key features: decentralized organization, rule-based autonomy, transparency, voting and governance. And of course, this leads to a very versatile use. Inspired by the content and language integrated learning (CLIL) approach, we can comprehend AI in education through 4 dimensions. Learning for AI, promoting AI literacy, covering its use, coding and development, while simplifying content creation. AI of learning, using AI-driven tools for personalized content and learning paths, akin to automatic content generators. AI for learning, creating AI-driven experiences that delve into the nature of learning with modular and scalable AI tools for diverse learning experiences. AI through learning, enhancing AI's capabilities through its application in education, reflecting its continuous improvement from interactions with learners and educators. One valuable insight from my research is that personal growth often arises from encountering gaps or alterity. In my teaching, I systematically motivate and provide opportunities for learners to make mistakes, as I believe that mistakes are an integral part of the learning process. As Franny Leotier aptly states, failure becomes a pool in which you learn new strokes. In traditional economies, failure is often penalized. However, a knowledge-based economy thrives on embracing and learning from failure. To grasp the concept of knowledge, consider this scenario with our Learning for Tech community. Imagine a university or school setting up Moodle platform. We have 3 options: outsource to a hosting company for simplicity but at a cost, rent a dedicated server for more control but with increased risk, handle everything internally, reducing expenses but raising the risk of challenges. The choice depends on our organization's context, balancing cost effectiveness and efficiency. However, there's another aspect to consider. Depending on your choice, you will engage with different service providers and skilled individuals. Option 1, 100% outsourcing, may only require a junior web developer. Yet, it also means complete dependence on external professionals, limiting knowledge acquisition within your organization. Option 2 requires a senior DevOps for complex tasks like SSL cryptography, firewalls, and IP configurations. It offers more control and the ability to integrate specific tools, leading to deeper technical knowledge. Option 3, handling everything in-house enables the creation of custom APIs, plugins, chat prompts, and templates, resulting in the highest level of knowledge acquisition within the organization. In a conventional factory model for knowledge supply, the process unfolds as follows. First, the company identifies its requirement, here an engineer, and sources these professionals from specialized agencies or educational institutions, typically universities. Second, educational institutions train and certify individuals, awarding qualifications like a master's in engineering. Then, certified individuals become experts, often specializing, for example, as mechanical engineers, and seek matching job opportunities. And lastly, companies specify required skills, which in turn are offered by certified professionals. This constitutes the current knowledge supply chain in this standard factory model, which of course goes in both directions. Before discussing AI's educational applications, let's briefly ponder the essence of knowledge. What do we create, share, and use in the knowledge economy? Share your thoughts in the chat. Learning entails actively participating in social groups and shaping one's identity through these interactions, as articulated by Etienne Wenger. In the context of the knowledge economy, knowledge can be analyzed like any other commodity. Knowledge is a fundamental human necessity, as emphasized by Manfred Max Neef and Pedro Lain in Tralgo, going beyond basic needs. Knowledge can be non-fungible, satisfying psychological needs. Knowledge can be fungible, taking the form of cultural norms or specific phrases. Knowledge can be commodified as certified competences in the job market or as a form of currency with certificates and titles. Knowledge can be a tool, directly measurable and performance-oriented. Thus, in the knowledge economy, human capital becomes the capital itself, uniquely replacing traditional means and production, or land as the core asset. In summary, human capital is the capital in the knowledge economy. We can view knowledge from two angles, as personal knowledge and skills, subjective and tacit in form of practical skills, intuition and hands-on learning. In contrary, artifactual knowledge is objective and explicit, externalized as data and information, codified, documented, and independently storable and shareable. It can be transferred in an economic sense, but requires interpretation and application, while personal knowledge is acquired through direct person-to-person encounter and shapes the individual's personality. In summary, learning involves interpersonal encounters in a digital context. Consider an encounter as an event where we resolve dilemmas through interpersonal exchange, resulting in meaningful solutions that impact our shared world. This process includes participants forming a community, a specific experience at a particular time and place, shared practices involving tools, interactions, and languages. This is distinct from online game experiences like kill counts or advancements known as experience points. In this context, a DAO driven by AI can also stand for decentralized artificial autonomous intelligence, or as referred to in my article, BALD, emphasizing the blockchain-encoded learning process. DAOs use tokens to impartially represent community wealth from successful experiences, including significant encounters. This involves tokenizing shared community knowledge and algorithmic evaluation. It's vital to acknowledge that humans are the creators of this wealth, contributing through their property and experiences. In response to the question posed at the beginning, what is learning? We consider these aspects. A. Encounter and exchange. Learning is akin to an encounter, drawing from concepts like dardesi, coming from intrabolain, self-giving, and interpersonal experiences. B. Shared meaning transfer. It involves the transfer of shared meaning, fostering community building. C. Learning experience. It encompasses elements like its impact on the community, the learning environment, paths, and rhythms. D. Certification and badges. Certification signifies task fulfillment and quality standards. Badges used in accredited courses represent competencies and experiences, making them credible and transferable. These badges, earned through peer review and collaborative tasks, serve as standardized tokens, communicating competencies and experiences. Angie Abdillah, CEO of Oldways, emphasizes we use technology to assert our culture and our identity. It's not about replacing who we are, it's about expressing who we are through these new mediums. She underscores technology as an extension of cultural identity, advocating for its role in preserving and expressing diverse cultures. This perspective is crucial in AI's integration into education, where it should respect and enhance cultural heritage. From our analysis, three distinct AI in education approaches emerge. First, standardization. This model A is used by the US and EU. Focused on teaching for AI, this approach prioritizes privacy and AI's role in improving literacy and skills by integrating NLP models for standardized learning. The model B, which is mostly used by Russia, India, or Nigeria, is measuring spectrums. It emphasizes AI for inclusion. This model addresses connectivity, challenges, and embraces diverse learning styles and impairments, aiming to adapt AI to a wide spectrum of needs. And last, Model C, which is mainly promoted by China, is profiling learning diversity. This approach enhances learning effectiveness while addressing objectification of the mind's issues, drawing from psychology and genetics concepts. It tailors educational experiences to diverse cognitive profiles, recognizing differences between AI and personhood. DAOs offer innovative educational platforms. Students engage, apply knowledge, and earn rewards, empowering them to control their learning journey. Unlike other initiatives focusing on climate change or supporting public school teachers, this approach prioritizes ethics, safety, and participation. AI isn't just replicating traditional models, but unlocking innovative approaches rooted in personal empowerment and community building. This perspective highlights AI's transformational potential, nurturing individuals and strengthening communities in education. When considering past teaching and working methods, it's unclear if we only changed our production methods or our understanding of how people learn also evolved. What seems missing is the idea of learning through practice, essentially learning by doing. This became obvious when Western companies outsourced manufacturing to other regions. They inadvertently lost opportunities for practical learning. Toyota's model illustrates how practical experience enriches understanding and contributes to overall company success. DAOs come to bridge this gap. They aim preserve practical knowledge and shared learning within their organization and network, transcending geographical distances. DAOs offer a simpler and more effective approach compared to the traditional factory model. They prioritize a continuous cycle of practice and learning, collectively nurturing knowledge and innovative ideas rather than relying solely on unique genius. Imagine you're an employer addressing a skills gap in your team. You turn to task boards, such as those offered by our partner Accento, to create tailored tasks assessing candidates' skills, work styles, and cultural alignment. Once you identify successful candidates, you carefully evaluate their profiles, seeking the ideal blend of skill, adaptability, and cultural fit. This objective approach minimizes subjective judgments and ensures the right person for the job, enhancing your team's capabilities and culture. Based on this insight, we are exploring four strategic directions to integrate our learning philosophy into the DAO. AI for literacy training, employing adaptive tasks and tools like Duolingo, AI Dungeon, and conversational apps for literacy enhancement. AI for profiling and gap filling, focusing on personal goal setting and skill gap identification using assessments and tools like Canary Speech. AI for social normation, leveraging AI for facilitating discussions on controversial topics using examples like MIT's Moral Machine and GPT. AI for self-awareness, encouraging engagement to enhance self-awareness and deeper understanding of the learning process. Here are key references that have influenced this work. I invite you to ask questions. Your input is crucial for understanding the need of concrete, specific challenges in the development of our DAO. Many thanks for your attention.